Okay, so now look at my desktop up here for a second. So what I did, I just went to, so I went to this icon right here, Logger Pro 3.9. And go ahead and get where, feel free to put the desks where you can see things. If you want to just get up and get where you can see things well. So in the lab, eventually you guys are going to actually be pulling up this program to acquire data, which is Logger Pro 3.9. I will install, it's not installed, they wipe it every year. I'll make sure it's installed before we do the first lab. When you click on that, switch to the running application, there we go, okay, and it just looks essentially like this, all right. I want to go to this experiment. So when I go to this experiment, I'll talk you through this when you do it. You're just going to go to the, you're going to open up the actual lab file. So you go open, and then you're going to go down to experiments, and you're going to go down to physics with Vernier right there. And then this is, it's actually in Vernier's catalog, it's lab number 3. So we would go to card on a ramp, and I double click that, and it opens it up, and then what it does is it does a bunch of stuff. It preloads the screen with all of the different types of graphs that we're going to need when we're going to acquire data. We want to be looking at stuff. We want to be looking at position versus time, velocity versus time, and acceleration versus time. We're going to set up a ramp, and we're going to explore the motion of a card on that ramp a little bit. Okay, and so this is where we're going to acquire the data. This is where you're going to take your screenshots, and et cetera, et cetera. Okay, so to do this, it's telling me I don't have anything hooked up, right? So first thing I have to do is I have to hook up the sensors, right? So you're just going to repeat what I'm doing here, and of course you're going to probably forget this, and that's fine. I mean, I'll be there to help you out with it. After a while, you'll understand. You'll get good at this. So I'm going to put this, what is this one? Oh, nothing. Okay, so I'm going to go, you plug in the USB cord, I mean, this is all going to be pretty familiar to you. And then this is the cord that's going to come with the sensor. There's going to be a box like this that's going to include the motion sensor, and then in addition to the motion sensor, it's going to have this cable, this special cable. Cable goes, for our stuff, it's going to go in the side. It's in the digital input on the side, either 1 or 2, doesn't matter. And then we're just going to hook this thing up to the sensor. When we hook it up to the sensor, it will recognize that you've done that. So I plug it in right there. Okay, and we're good to go. Okay, it's in. It saw that. All is good. If I want, here, I'll just show you what this does. Like if I want to collect some data, right, it's just going to collect data based on how this thing moves towards the box. There's a few settings in here that we'll talk about. This is all good. Now we have to set up the ramp. I'm going to get one. Hold on one sec. One sec. We've got these very expensive, highly specialized, I believe they call these things ramp incline box, or old textbooks. This is what the ramp looks like. It's an extruded aluminum ramp, very high quality, low friction, etc., etc. So let's set this thing up. Let's set it up right here. So we'll just use 2 things here. Okay, so something like this. Now, there's more to it, though. We got to be able to adjust the ramp in such a way that we In many cases, we're going to want to get it level, not in this case, but in the future, we may want to get it level. So we've got these feet. The feet go on the ramp. If you flip the ramp over, you can see that there's a channel down the middle where this nut goes right on the back. So I can just kind of feed that into that little channel, and you'll see how it works. If you want to come up and look, feel free. Look and see what I'm doing. Put one foot at that end. Put one foot down here. Okay, this one I've also got attached to. Okay, this one I've also got attached to this rod that's going to hold the motion sensor in place. So I don't break my fancy microwave like this. Okay, and then these little screws on the top, every kind of see this? These screws on the top allow me to level this thing. For our purposes, we don't really have to worry about that because it's at an incline anyway. But we want it to be fairly level side to side. Good enough. The motion detector is going to go on here. There's a little screw on the back. So I can set this thing up on here. Okay, now everybody come up here real quick. I'll show you something. Just file through here. When you look at the motion detector, notice that there are going to be two settings on here. Just kind of file through and take a look at this. There's a setting for the cart, and then there's a setting for big things like a person or a ball or something like that. We want it set on cart. Okay? Cart gives you a little better precision, but it's not quite as maybe as accurate. I mean, it's harder to see something. It sends a more directed beam, so you get better results if you can actually, I said that backwards, when I said it made sense. It sends a more directed beam with a smaller angle. So if you have an object where it's predictable where it's going to be, you want to use that one, because it's going to give you better results. If you're trying to see something that's moving around, then you use a little wider cone. All this is it's ultrasound. It's just going to send out a cone of sound. It's going to bounce off and come back to it. Okay. I found that if this thing tilts up ever so slightly, you get a little better results. Okay. The other thing is, go ahead and either sit down or come over this way, because you don't want to have a lot of things happening in the background. If things are moving in the background of the experiment, it's going to degrade the results a little bit. Okay. So we got this set up. Here's our cart. Okay, so what do we have to do next here? Kind of pick up your sheet here and read along with it. So it says we're supposed to preliminary questions. Okay. Yeah, this isn't going to work quite as well if we're doing this as a group. I didn't really think about that part. Okay, let's talk about this. Consider the changes in motion a cart will undergo as it rolls up and down the ramp. Make a sketch of your prediction for the position versus time graph. So let's take a second, just go with your groups, and let's just do these quick preliminary questions to get ourselves thinking about this a little bit. You can just graph this. I've got graph paper up here. Just as your group, why don't you come up with one graph for each of these three preliminary questions. And you don't have to be right, but just try to be. I'm not going to penalize you if you don't get it right, but think about what you imagine the position versus time graph is going to look for. If here's the motion sensor, right, and all I'm going to do for the first part is I'm just going to push this thing up the ramp, no further than that, and we're going to observe the motion as it moves up and down the ramp. Okay? Okay, keep in mind that it's measuring this distance, so it's starting, now think about what this might look like. The position is going to start big, it's going to get smaller, and then it's going to get bigger again, right? Does that make sense? Because it's measuring the position relative to here, okay? So think what that graph might look like if I'm graphing position versus time. So time is on this axis, position is on this axis.
Position from the sensor?
From the sensor,
So it's
yeah.
going to start small, but it starts near the sensor.
So it's going to start, well, I'm going to start it down here, and I'm going to do that with it. So it's going to start far away, it's going to move towards the sensor, slowing down, and then going to accelerate back down the ramp away from the sensor. So as in your groups, get a picture of that. Collaborate on that, and then take a picture with your camera is fine, or with your phone. Take a picture of that so you have a picture that you can email to yourself.
Did you mean time on?
So time is going to, oh, I'm sorry, other way around, I'm sorry, yeah, position, sorry, I got it backwards. Position's on this axis, time is on this axis, sorry. Time is, and that's the way it's always going to be in physics, because time is the independent variable. We know the independent variable goes on the horizontal axis. The dependent variables are going to be position, velocity, and acceleration, right? You're going to do one prediction graph for each of those, okay? What's it going to look like?
So we're doing off here right now.
Yeah, just talk about it, take a few minutes and just talk about what you think it's going to look like. Just get one good picture for the group, and everybody take a picture of that with your, or one good graph, everybody take a picture of it with your camera. Or you can share it, one person can take a picture and just email it to everybody else, that's fine. But you need to have that to put in your lab.
It doesn't really matter what extrusion graphs. So you start all the way through. I know.
Everybody agree with that? That makes sense?
I know.
Okay? Take a picture. You're gonna have to submit that as a digital file for your lab. Yes, on data sharing.
Do we just put the numbers?
Yeah, do we just put the numbers in the HTTP?
I think you have to put the whole thing.
No.
But you were able to do just the numbers? Okay, never mind, just the numbers. You have to include the port number at the end, though, the colon 8080 at the end. Okay. Okay, so once you've done that, now we get to start doing something, all right? So I require a lab assistant. This will be a rotating honor to be the lab assistant. Who wants to be lab assistant? Okay, first lab assistant right here. Come on up. So here's what we're going to do. We're going to take a few trial runs here, but I'm going to actually, maybe I'll take two lab assistants. Need another lab assistant. Right here. Okay, so you can decide how you split this up, but one person's going to launch the cart, which means you're just going to, now, why don't you come on up where you can see this a little bit. So when we're launching the cart, you guys tell me, we want to get data after it's left my hand, right? So how do we want to be, when we're doing the procedure here, we want to make sure we're doing things in a way that's going to make sense. Do I want to push it like this then?
No.
No, what do I probably want to do instead?
Flick of the wrist.
I want to just, a little flick of the wrist, right. So one person's going to be the flicker, one person's going to be the catcher in cases we got to protect this thing. If it's going too fast, just don't let it go off the end,
Just
right?
why don't you just put something there so it doesn't...
Well, because it'll interfere with the thing, so.
Just put a little break.
Well, it kind of messes with it. So somebody's just going to be here that's got good skills, and just if it gets too close, then you're just going to catch it, right? Okay, if it looks like it's going too close. And we'll just redo it, okay?
Who's the catcher?
I don't know, one of these two. These are the labbies for the day. Okay, and when I say go, you're just going to do that. Okay, and then I'm going to go ahead and collect data over here. I'll push the acquire data button, and we'll see what happens. We're probably going to have to make a few adjustments, but
Can I do a practice run?
practice it, you bet. Practice run.
Oh.
Okay, good thing we had that practice run. You make sure, you got to make sure it's in the little, there you go, in the little grooves. Okay, there you go, maybe just a little harder. Oh, that's a good one right there, okay. All right, so let's try this. So I'll tell you when. Ready, go. Okay, good. So we got some data. Let's do some tweaking here. So look what happened. We'll do this again, but we got some data for position, right?
Actually, no, I was looking at that.
Okay. So you kind of get an idea if you got it right. Now, what's wrong with the velocity? How come it's not showing up?
It is.
It is, but why does it look so terrible? Because what? Say it again. What's
Graph is too far out.
It says
Yes, so
for 50 meters.
50 meters per second? It's pretty fast, right? Is this thing going remote? Oh, are we done?
Yeah.
Just we're starting to have fun. Okay, we'll pick it up tomorrow.
Let's just skip last period.
Yeah, exactly.